looking here at a half wave rectifier, and we want to try and find out how that works. So let's assume that we have this signal coming in. Okay? At the very beginning here, Vx should be virtual Earth, should be 0. But let's assume it is slightly positive. If it is slightly positive, okay, the positive terminal here is held at ground. So that means what? The negative is greater. This output here is going to want to conduct, isn't it? We're going to have a negative signal here. If we've got positive at this node and we've got negative at this node, this diode is reverse biased. Okay? As we're negative here, okay, what's happening here? This one is forward biased. So this circuit effectively looks like that diode isn't there, and we have our feedback resistor and we have our input resistor. So whenever the waveform is positive, okay, this circuit is our input waveform. We will have, I'll draw in a different colour to make it clear. Our output waveform will follow the input waveform like so. Okay, whenever we have a positive signal, we're going to have the negative signal. So it behaves exactly with gain of -1. Okay, that's what's important. I'll go my colour back to red, and we'll have a look at the negative half cycle. So down the bottom here, again, we have our input signal coming in. What we're focusing on is the input going negative. So this one was the input going positive. We're looking at what happens when we get a negative signal coming in. Our virtual Earth, Vx, as we would expect, we want our Vx to be, well, it's supposed to be 0, isn't it? But we know that it will be, in effect, slightly negative. If it is slightly negative, and this is ground, this node is now at a higher potential than this one, therefore this forward biased. Okay, to our output. Now what we see happen, our output signal, okay, this one now has to be in effect reversed biased, comes through here. So what's happening, we're feeding this signal, whatever it happens to be, back to here, and then we're tapping that virtual Earth. So that means that if I look again, and we'll draw our input signal here, what happens in our design, we're only really concerned at the moment with the negative portion. We've already proved that this is what happens in the positive portion. Okay, as we go negative, we're driving a voltage into this node to cancel the negative signal. So basically we end up with following this 0 volt line. Okay, if you look at the simulation data, when you do that, what we will see is we'll see very, very, very small signals, because what's happening, the gain AV of this amplifier as you pass through is what is being used to negate the negative signal coming back in again, so what comes out here is 0 volts. So this precision rectifier needs 2 diodes. They work on the basis that Vx is slightly positive, slightly negative. For the inverting amplifier, we have the diode in reverse bias and forward bias, and when we go negative, we have them in forward bias and reverse bias. So now we can clearly see that this is the waveform that we get. We have a half-wave rectifier with a gain of -1 inverting our input signal. And that's how the precision rectifier works. Now the only other thing you need to think about is, how do we make a full-wave rectifier? Well, the question you should ask yourself is, what would happen if we add this signal that we've got coming out, okay, to the input signal? If we add these two together, okay, what will we get? Well, if I add the positive sinusoid and a negative sinusoid, I'm going to get nothing. If I add nothing to a negative sinusoid, I'm going to get a negative sinusoid. Okay? So that's the sort of signal that I get if I added those two waveforms together. Now what would happen if I add 1 times the input signal and I add 2 times the output signal together? So let's draw that. 2 times the output signal is a signal that goes all the way down here and then does nothing. And my input signal would be substantially smaller. So if I add those two together, that's 1 times, that's 2 times. I'm going to end up with 1 times and then 1 times. Okay? So again, on the way that this works, we perform a half-wave rectifier, we feed back the input signal to an inverting summing amplifier, and we feed those in with the output here with a gain of -2. So we end with this waveform here.